Hello friends, welcome back to our channel. Today in part 9.3 of our Mastering Multi-Threading series, we will explore the concept of thread interaction or thread signaling into the world of thread synchronization in C#. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. Thread interaction or thread signaling for thread synchronization in C#. Thread interaction or thread signaling is a crucial technique in multi-threading programming. It involves one thread waiting for a signal from one or more threads before it can proceed. This ensures orderly execution and coordination between threads in multi-threaded environment. So there are several ways to achieve thread interaction in C#. Let's take a look at three common methods for thread interaction. Method 1, event wait handle. These handles include auto reset event, manual reset event, and manual reset event slim class. They allow threads to communicate with each other through signaling and waiting for signal. Second method is monitors wait and pulse or pulse all method. So these methods provide a way for threads to wait for a specific condition to be met before proceeding. They are essential for inter-threaded synchronization and coordination. Our third method involves countdown event and barrier classes provided by the .NET frame. So these synchronization techniques help manage and coordinate the activities of multiple threads in a concurrent or parallel program, particularly when you need to synchronize a group of threads or tasks. Okay, now we got some overview of these three common methods to achieve thread interaction in C#. Today, we will deep dive into the first method, which is event wait handle. That includes auto reset event, manual reset event, and manual reset event slim classes. Other two methods we will cover in upcoming videos. Thread synchronization, auto reset event in C#. Okay, so now let's dive into the details of auto reset event, which is a powerful technique for thread synchronization. So what auto reset event is? Auto reset event is used to enable signal communication between threads. It temporarily blocks the current thread with wait one method until another thread signals it using set method. Important point over here is it allows only one waiting thread to proceed and it automatically resets itself to a non-signal state after one thread passes through. Use auto reset event, we need to follow just three simple steps. What are those steps? Step number 1. Create an instance of auto reset event class. So we start by creating an instance of the auto reset event class, specifying its initial state as signaled or non-signaled. How we are going to create an instance of this auto reset event class? So for that, we need to write something like this. Static auto reset event obj auto reset event is equal to new auto reset event false. So here false basically talks about that we are setting the initial state to the non-signaled. If it is a true, then it means we are going to set initial state to be signaled one. So that is the difference between false and true value when we are passing in the constructor of the auto reset event. Step number 2. Put the current thread into a waiting state until it receives the signal. Here, using the wait one method, we pause the current thread until it receives a signal. That's why we have written obj auto reset event dot wait one. Step number 3. Set the state of the event to signaled, allowing one waiting thread to proceed. So finally, we use the set method to allow one waiting thread to proceed. That's what we have written obj auto reset event dot set method. So these are the three steps for the auto reset event by which we are going to implement thread interaction. Okay, so let's switch to the Visual Studio and see all these things in action. Here we are on Visual Studio. This demo we will explore the auto reset event thread signaling technique. But before we delve into the details of how it works, let's first discuss the concept of synchronization issue. Once we have a solid understanding of the problem, we will proceed to resolve it using the auto reset event thread signaling technique. For that, what I have done, I have created one console application named thread signaling in C#. As program.cs. Program.cs file, we have one class named program that has static int counter variable that I have initialized with 0 value. Then we have one main method, which is an entry point of this application. Here I am just printing this statement, demo of synchronization problem. Then I am setting the name of the current thread as a main thread. Then what I am doing, I am creating one thread. What I have written thread is equal to new thread set count. Here set counter is nothing but the thread function. What set counter thread function is like this is the static void method set. It is just printing this state into set counter method. Then we have one for loop that is going to get executed 10 times. Then is just going to get incremented counter value by 1 each run of this for loop. Okay. Then finally I'm just printing. That's what this method is doing. Now come to the main method. Here what I have done, I have given this name of this created thread as a thread1. Then just starting this thread. After starting the thread, I'm just writing this state counter value printed by thread dot current thread dot name, and this is the counter variable. Then there is a console. That's what this program is written. Ideally, what we are expecting from this program is first it's just go and calculate this counter value and set this count. That's what we wanted to print this counter variable, the main method by main thread. I'm expecting the counter value that is going to get printed from main thread value should be 10, but it's not going to happen due to synchronization issue. So let me execute this program and show this output. Okay, if you see this output got appear into this here, if you see the first statement got printed counter value printed by main 0. This set counter method just printing entered into set counter method exiting between it, just setting this value counter value to 10, but it is of no use because this statement got printed. This is nothing but a synchronization issue. So this problem we are going to resolve it with the help of auto recent thread signaling technique. In order to save the time, I have modified this program and I have implemented auto recent event thread signaling technique over here. In the same program, as a part of step 1, what I have done, I have created an instance of this auto recent event. What I have written a static auto recent event equal to new recent event. Here I am mentioning false. So because I am just going to set initial state is none signaled. Okay, so this is the step number 1. Step number 2, what I am doing, I am just putting the current thread into a waiting state. For that, I have used this wait one method of this auto recent event. It is just going to hold this main thread, wait until receive the signal. The third change what I have done here in this set counter method, I have written step 3. Basically, I am just using this set method of obj auto recent event class. What this statement is going to do, it is just going to set the state of the event to be signal. Okay. So that's what this is step number 3. So now let me go and execute this program. Okay, if you see this output got appear into this console. First this entered into set counter method got printed, then exited from set counter method got printed. Then this statement got printed with the help of main thread. But we are going to get of 10. Basically, auto recent event here what it is doing, it is making this thread to wait until it receives the signal. Here, step number 3, when this execution completed successfully, then we are setting, informing this waiting thread to proceed further, right? We got the signal over here, then this statement got printed. That's what we see this output over here, counter value printed by main thread. So this synchronization problem got resolved, right? Okay, so I have modified little bit this auto recent event program. What the modification I have done, I have written this statement object auto recent event dot set. So basically from here I am just sending the signal waiting thread. What is the waiting thread? This is the thread 1, right? So here I put this wait 1. So it will wait until we get this signal. From here I am just sending the signal. This statement is just going to get executed. Let me go and execute this program and show output. Okay, so output got appear into this console, right? Entered into set counter method printed by thread 1, exited from set counter method printed by thread 1. Counter value printed by main thread, the 10 value. Then counter value printed by thread 1, that is 20. Here if you see the flow, what it is happening, the first this statement got printed, right? First thing. Then this thread 1, right? It is just going to call this set counter method. So this two statement got printed because I put this wait 1 method. This statement is not going to get executed until it is signal, right? For that, this statement up to here it got printed, right? Then here we have send the signal. Okay, here what I have done, I have sent the signal. So this statement got the signal and this statement got printed, right? Here I am sending the signal to the thread 1. So here it will receive the signal and this for statement and this console statement is just going to get printed. That's what we saw, the output got printed. So main thread got printed, counter value 10, main thread printed counter value 10, thread 1 printed counter value as 20. Was the for loop again executed for 10 times and the counter value got increased by 10. 10 plus 10 is equal to 20, it got printed. So auto recent event allows only one waiting thread to proceed. Right? That's what automatically resets itself to a non-signal list. Thread synchronization manual recent event in C#. Let's move on to the manual recent event, which is another valuable technique for thread synchronization. Manual recent event is quite similar to auto recent event, which enables signal communication between threads. It temporarily blocks the current thread with wait one until another thread signals it using set method. The only difference between auto recent event and manual recent event is it allows all waiting thread to proceed instead of one. The event remains in a signaled state until explicitly reset using the reset method. To use manual recent event, we follow the same three-step process as we did with auto recent event. What are those steps? Step number one, create an instance of manual recent event. For that, we need to write something like this: static manual recent event obj manual recent event equal new manual recent event false. Here I'm passing the value as a false for the initial state, because we are setting the value here initial state as non-signal. If we are supposed to pass to true, then it means we are going to set the initial state to be signaled one. So that is the difference between false and true, similar to the auto recent event class, right? Coming to the step number 2, we need to put the current thread into a waiting state until it receives the signal. For that, we need to use this wait one method. That's what I have written, obj manual recent event dot wait one. This statement basically making this current thread into a waiting state. Finally, the step number 3, where we are setting the state of the event to the signaled one. So how we are going to do that? For that, we need to use this set method. That's what we need to write, obj manual recent event dot set. This statement basically sets the state of the event to the signaled one and allowing one or more waiting thread to proceed. Okay, quickly switch to the Visual Studio and see all these things in action. So here we are in Visual Studio. Here we are going to see the same problem what we have seen in this auto recent event, right? So what we have done, instead of as auto recent event, I have just replaced with this manual recent event. I was creating an object of auto recent event, but now I am creating the object of manual recent event as a part of instance create. Here, step number 2, I'm just putting the current thread into waiting state. Here, just using this wait one method we did for this auto recent event. Then the set counter method, I'm just calling this set method of this manual recent event. Previously, wherever we are using this auto recent event, have just replaced with the manual recent, and it is going to work as it is. We go and execute this program. Okay, now if you see, this output got printed demo of resolution of synchronization problem using event, entered into set counter method, exiting from set counter method, counter value printed by main method, the value got printed as a 10 because we have this for loop. So just implemented this counter value to 10. That's what we access this counter variable into this main thread, and that printed that value and got this value as it. Now I have extended this manual recent event program little bit further. What I have done, I have used this again, this wait one method, two times wait. Previously it was to here. Now what I'm doing, I'm just using this wait one method again, then printing this statement. Counter value printed by thread dot current thread dot name. Basically, I just wanted to show you that one set method of this manual recent event is just going to unblock all the waiting thread. That set method of the manual recent event class, it is just allowing all waiting thread to proceed. The event remains in a signal state until explicitly reset using the reset method. So here I am not using the reset method. I am just using this set method only one time. It is just going to ignore this wait one method and print this state. Let me go and execute this program and show this out. Okay, so output got appear into this console. See, this entered the set counter method printed by thread 1 got printed, exited from set counter method printed by thread 1 got printed, then counter value printed by main thread 10. Then again this counter value printed by main thread got printed as a 10. Here, if you see, I have issued only one set method of this manual recent event, right? And it is just going to, unblock all the waiting thread. That's what this statement got printed, and this statement also got. So we have seen that set method of this manual recent event class allows all waiting thread to proceed. The event remains in a signal state until we go and explicitly use the reset method. Thread synchronization manual recent event slim in C#. Now let's explore manual recent event slim, a lightweight and efficient alternative to manual recent. So manual recent event Slim offers similar functionality to manual recent event but with a better performance, especially in the scenarios where wait times are expected to be very short and events don't cross process boundaries. And this manual recent event Slim class introduced in .NET 4.0. To use the manual recent event class, the process remains the same. The step number one, we need to create an instance of this manual recent event Slim class. For that, to write something like this: a static manual recent event Slim obj manual recent event Slim is equal to new manual recent event Slim for. So here false means we are setting the initial state to none signal. If you are putting true instead of false, then it means we are going to set the initial state to be signal 1. Okay. Coming to the step number 2, here we need to put the current thread into the waiting state. Here we are going to use the wait method instead of wait one. That's what I have written, obj manual recent events dot wait method. Then finally, step number 3, we need to set the state of the event to be signaled, thus allowing one or more waiting thread to proceed. How we are going to do that? For that we need to use this set method. That's what I have written, obj manual recent event slim dot set method. Okay, so these are the 3 steps we need to follow in order to implement manual recent slim class. So now switch to the Visual Studio and see. So here we are in Visual Studio. Here we are going to see the demo of the manual recent event slim. As we know that manual recent event slim is an alternative to the manual recent event. It is a lightweight and it has performance benefit, right? So here what I have done, I have just replaced this manual recent event to manual recent event slim class. Everything is same except this wait method. So this manual recent event slim does not have wait one method. It has wait method. Let me go and execute this. Okay, so output got appeared into this window, right? And if you see, the same output got appeared. There is no difference at all. Entered into set counter method exiting from, and this counter value printed by main thread 10, right? We are achieving the same output even though we are using manual recent event slim class. Auto recent event versus manual recent event versus manual recent event slim in C#. Auto recent event, manual recent event, and manual recent event slim are thread signaling techniques C# that are used to coordinate and synchronize multiple threads. So here we are going to see the comparison among these against 4 parameters. Number 1, reset mechanism. An auto recent event allows one waiting thread to be released when the event is set. Once a thread is released, the event is automatically reset. Whereas manual recent event allows multiple waiting threads to be released when the event is set. Event remains set until it is manually reset. Manual recent event slim also allows multiple waiting threads to be released when the event is set. It is designed for better performance than manual recent event in scenarios where frequent set and reset operations are needed. Number 2, performance. Auto recent event is less efficient than manual recent event or manual recent event slim, especially when many threads are contending for the event. Whereas manual recent event has better performance compared to the auto recent event, but can still have a performance issues in highly contended scenario. Whereas manual recent event slim is designed for better performance and is recommended for scenarios with frequent set and reset operation, especially in high contention scenario. Number 3, simplicity. When we talk about the simplicity, auto recent event is relatively simple to use and understand. It's suitable for scenarios where you need a simple mechanism for one-to-one thread synchronization. Whereas manual recent event is straightforward but provides more control compared to auto recent event. It's useful for scenarios that require one-to-many thread synchronization. Manual recent event slim offers a more advanced API and improved performance, but it might require a bit more effort to use effectively due to its additional features. Finally, number 4, use cases. Use auto recent event when you need to ensure that only one waiting thread is released when the event is set, such as in scenarios where you want exclusive access. Use manual recent event when you need to release multiple waiting threads simultaneously when the event is set. For instance, to signal the completion of a task for multiple threads. Consider using manual recent event slim when you need the performance benefits of a lightweight synchronization primitives for scenarios with frequent set and recent operation. Now we have compared these 3 thread signaling techniques in C# that are used to coordinate and synchronize multiple threads. That brings me to end of my session. Sum up. This video, we explored the concept of thread interaction and thread signaling. We provided an overview of three common methods: event wait handles, monitors wait pulse methods, and countdown and barrier classes. Specifically, we delve into the first method, which is event wait handling. Discuss how to achieve efficient and robust thread synchronization using auto reset event, manual recent event, and manual recent event slim. I hope you found this video both informative and valuable. Upcoming videos will discuss monitors wait pulse methods, countdown and barrier classes in detail for thread interaction. So stay tuned. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.